Hi, this is the Science Chef. You're welcome to the fifth part of a series on the 2023 JAMB Preparations. In this video, we'll be answering organic chemistry questions on the 2021 UTME examinations. If you'd like to watch our tutorials on the first four series, especially our last tutorial on the solutions to year 2022 UTME organic chemistry questions, kindly check the links in the description. So let's start. Question 1. Which of the following types of hybridization is found in tetrahedral molecules? This question is on the hybridization of orbitals. First, what's the hybridization? Hybridization is the mixing of orbitals of different energy levels, or the blending of orbitals of different energy levels to form a new set of orbitals with a new energy level. For example, let's say you have the s and the p orbital. Let's say the 2s and the 2p orbitals. Remember, the 2s orbital is lower in energy level than the 2p orbitals. So these two orbitals can blend together to give us a new set of orbitals called what? The sp orbitals. Called the sp orbitals. Right? These four orbitals can blend together to give us a new set of four orbitals called what? sp3 orbitals. Or two out of these three p orbitals can blend with this one orbital to give us what? Three new sets of orbitals. To give us three new sets of orbitals called what? sp2 orbitals. Or only one of these p orbitals can combine with this s orbital to give us two new sets of orbitals called what? sp hybridized orbitals. All these new sets of orbitals are called what? Hybrid orbitals or hybridized orbitals. Their energy levels are in between the energy levels of what? The s and the p orbitals, right? So based on the JAMB syllabus, these are the three types of hybridization that you are expected to learn about: the sp3, the sp2, and the what? And the sp hybridization. Now when it comes to the sp3 hybridization, since there are four orbitals here, we're always using what? Carbon as a case study. No, carbon has this configuration: 2s2 and 2p. 1, 2. So 2p. So these two orbitals can blend together to give us a new set of orbitals like this. Can give us sp3 orbitals, where the electrons in the s orbital will unpair and be promoted to fill one of the vacant orbitals in the p subshell. So we now have something like this: 1, 2, 3, 4. So in that case, when this happens, we say that carbon is what? Tetravalent. That's why you have carbon like this: 1, 2, 3, 4. So we have something like this. So with this now, carbon can now bond with 4 hydrogen atoms, right, to form your methane. Or it can combine with another carbon atom with 3 hydrogen atoms each to form your ethane, right? So here you can have your CH4, and here you can have your C2H6. Now from this CH4, these electrons will repel themselves to the four corners of the tetrahedron, where the bond angle between the two adjacent carbon hydrogen bonds will be about what? 109.5 degrees. And this shape or this geometry is called what? Tetrahedral. This is the tetrahedral geometry or shape. So this means that it's the sp3 hybridization that gives us the tetrahedral shape or geometry of organic molecules, right? Therefore the answer to this question is what? C. So let's look at the other ones: sp2 and sp. In sp2 there will be what? 3 bonds, 3 orbitals will be involved in the bonding. So we have something like this. This will be sp2 and what? And a p unhybridized orbital, right? So when that happens, that's when you get your carbon-carbon double bond. And the bond angle in the sp2 hybridization is 120 degrees, and the shape is trigonal planar. While the sp hybridization will give you a linear shape with the bond angle of 180 degrees. Something like this. So to learn more about hybridization in organic molecules, you will have to watch our video or tutorial on hybridization. We've added the link in the description. Note that a compound can exhibit these 3 types of hybridization in its molecule. It means that if it has double bond, triple bond, and single bonds in its molecule, it will all exhibit sp3, sp2, and sp hybridization. So how will you know? The carbon that has a bond, the hybridization around that carbon will be sp3. The one with a double bond, carbon-carbon double bond, the hybridization around that carbon will be sp2, while the one with a carbon-carbon triple bond or any form of triple bond would be an sp what? Hybridization. Are we together? So the answer to this question is what? sp3 hybridization, which is C. Question 2. Detergents are much better than soap for laundry because the major difference between detergents and soap is their structure. Detergents are called soapless detergents with the structure, so detergents are called soapless detergents with this structure. Now, last tutorial we described the structure of soap. We told that soap is made up of a hydrocarbon tail and an ionic what? Head. The hydrocarbon tail is hydrophobic, while the ionic head is what? Hydrophilic. Now in detergent, yes, the detergent is also made up of what? Hydrocarbon tail and hydrophilic what? Head. But the major difference is that in the case of the detergent, instead of the head being C double bond O minus Na plus or K plus, right, it is what? SO3 minus Na plus or K plus. Now this SO3 minus is from the sulfonic what? Acid. Sulfonic acid. And you can also see that there's a benzene ring here, right? Detergents are made from what we call what? Linear alkyl what? Sulfonates. That's LAS. Or what we call linear alkyl what? Benzene what? Sulfonate, right? They are not made from fatty acids or fat and oils like soaps are. Rather, they are made from what? Linear alkyl sulfonates or linear alkyl benzene what? Sulfonate, right? The major disadvantage of soap is that it forms what? Scum when used with what? Hard water. What's hard water? Hard water is a sample of water that does not lather readily with what? Soap. Any water that cannot lather or foam readily with soap is said to be what? Hard, right? And of course, you have types of hardness. You have temporary hardness and what? Permanent what? Hardness, right? And because of that issue of not being able to form lather with what? Soap, there's always the formation of scum when you try to wash your clothes with what? Hard water using what? Soap. And why is that so? Because the calcium ion in the hard water will do what? Will react with the soap to form what? An insoluble what? Precipitate. An insoluble substance or solid, which is called what? Scum. Right? So scum. So the formation of this scum leads to the what? Wastage of what? Soap. Why is that so? Because until all the calcium ions are removed from the water, there's no way the soap will lather with the water. And once the soap does not lather, there's no way it can wash your clothes. Are we together? Now, the value of R here is C17H35, right? Which means that the formula of this soap is what? C17H35 COO minus Na what? Plus that's sodium octadecanoate. That's to show us that soap is what? Is a compound. Sodium octadecanoate. It can either be sodium octadecanoate or potassium octadecanoate. So when there's an exchange of radicals, right, the sodium ion will replace the calcium ion in the solution. So the calcium ion will now take the place of the sodium ion in the soap molecule to form what? An insoluble calcium octadecanoate, right, which is seen as a what? Precipitate, dirty precipitate, which is what we call what? Scum, right? So the soap can either be sodium octadecanoate or potassium octadecanoate, depending on what was used to make the what? Soap. So that is the disadvantage of soap. Now when it comes to detergent, the head of the detergent, this sulfonic head of the detergent or sulfonate head of the detergent is very what? Soluble in hard water, right? So because the calcium sulfonate that will be formed is soluble, it will not do what? Form a precipitate with hard water, which means that it will be very easy for the detergent to foam with the what? Hard water when compared to what? Soap. So that's the major advantage of detergents over soap in what? Laundry. So the answer here is what? C. Question 3. Octane number is highest in petrol containing a high proportion of A. Octane 2,2-methyl pentanes, C. 2,4-dimethyl pentane, D. 2,2,4-trimethyl pentane. Now what is octane number? Octane number is simply a measure of the proportion of what we call isooctane. A measure of what? Isooctane in a given blend of what? Petrol. Now, there are always two compounds that are used to determine the octane number of a given sample of what? Petrol. They are what? Isooctane and N-heptane. depending on the proportion of isooctane present in that blend of petrol, then that will give you a what? The octane number of that petrol. If the proportion of isooctane present is 80 and the other one is what? 20. Two of them must always add up to what? 100, right? Then the octane number of the petrol will be what? 80. Now, if the octane number is what? 100, it means that the proportion of isooctane there is what? 100, while the N-heptane is what? 0. And the quality of a given blend of petrol increases as the octane number does what? Increase. The higher the octane number of a blend of petrol, the higher the quality of that what? Petrol. So every driver, every car owner will always want to use a petrol that has an octane number of what? 100, right? In other words, it's purely what? Isooctane, right? So that's why you are told in this question that octane number is what? Highest in petrol containing high proportion of what? It's actually what? 2,2,4 trimethyl what? Pentane. 1, 2, 3, 4, 5, right? That's 5 pentane, right? 2,2,4. 1, 2, 2. That's 2, 2, 3, 4. Right? So this gives us what? The formula of 2,2,4 trimethyl pentane. Remember, all these are what? Hydrogen what? Atoms. So you can just complete it. So that gives the structure of 2,2,4 trimethyl pentane, which is what is used as a measure of the octane number of a blend of what? Petrol, right? And 2,2,4 trimethyl pentane has anti-knocking what? Properties, which improves the efficiency of the what? Of the engine of a car. Are we together? So therefore, the higher the proportion of 2,2,4 trimethyl pentane present in a given sample of a blend of petrol, right, the higher the octane rating of that petrol. So the answer is what? D. Question 4. The compound given above is, before I start explaining this, if you want to know how to name hydrocarbons, right, that's your alkanes, alkenes, and alkynes, you will need to watch our videos on naming of what? Hydrocarbons. That's naming of alkanes, alkenes, and alkynes, whose link I've added in the what? Description. So let's look at this. The first thing we are going to do is to identify the functional what? Group. Does it have a functional group? Yes, it has, which is what? The carbon-carbon what? Double bonds. Fine. We have identified the functional group. The next point is to do what? Look at the longest carbon chain containing the what? The functional group in any given direction. So there are many directions in this molecule that contain the carbon-carbon double bond. First here is 1, 2, 3, 4, right? That's 4. The other one is 1, 2, 3, 4, 5. Good. Those are the two parts of the molecule that contain the carbon-carbon what? Double bond, the functional group. But before we name the compound, we must remember that any organic compound is named as prefix plus what? Root plus suffix. Now the suffix is from the homologous what? Series, the family of the organic compound, which in this case we have established that it is what? The alkene, because of the what? Functional group. So because of that it ends with what? In. Now the root is based on the number of carbon atoms present in the longest chain of that molecule, right? So in this case is what? 5. And 5 is what? Pent. C5 is what? Pent. C4 is but. C3 is prop, right? C6 is hex, and so on and what? So forth. So now, since it is pent, we write our what? Pent here. Now, what is the position of this functional group, which is in? Now, the functional group takes the highest priority. The functional group is like the landlord. I want to liken this molecule to a building that has what? 5 rooms. 1, 2, 3, 4, 5. And the landlord, which is the functional group here, must take the smallest possible room number it can get, right? Whichever room the landlord takes, right? So when you are numbering those rooms, you must start in a direction that will give that landlord's room the smallest possible what? Room number. So here, this is the longest chain. You have to number this longest chain. You can start from here or you can start from here. If you start from here, the first carbon atom carrying the functional group is what? Carbon number what? 2, right? But if you start from down, this will be 1, this will be what? 2, and this will be what? 3. If you start from the bottom and move to the top, right? You find out that the first carbon carrying the functional group, the double bond, will be what? Carbon number what? 3. So we have what? 2 and what? 3. Which one is lower? The rule says that the position of the functional group must be the lowest possible, right? So which in this case is what? 2. So that was what? 2. That's 2 what? In. So pent plus what? 2 in. Now our prefix here. How many carbon atoms do we have in this molecule? there are 1, 2, 3, 4, 5, 6, 7. We have 7 carbon atoms, right? But we have been able to account for only what? 5, right? Now it means that there are 2 other carbon atoms which have not been what? Accounted for. Now when naming an organic compound, the name must reflect all the number of what? Carbon atoms there. So what are those other 2 carbon atoms that are not part of this parent chain? This and what? This. And this is what? CH3. Remember our alkyl group in our last tutorial? Yes. This is also what? A CH3. These are what? Alkyl groups, and both of them are the same. And this CH3 is what? Methyl, right? And since they are the same, we can say it is what? Dimethyl. You can call them what? Dimethyl. But their positions, their room numbers must also be taken into what? Consideration. In this other methyl, this methyl is sharing the same room number as the landlord, which is what? 2, right? And this other methyl is sharing the 3rd room number, right? Which is what? 3. So when writing, we use commas, 2, what? 3 to separate the numbers. We use commas to separate the numbers. Why we use what? Hyphen to separate numbers and what? Letters. So the prefix is basically the substituents or the attachment that are not part of the what? Parent chain, if any. If there's any substituent or any attachment that is not part of the parent chain, it will fall under the what? Prefix, right? Of course, since there are substituents here, or since there are other attachments here that are not part of the parent chain, therefore this molecule will have what? A prefix. So if you now put everything together, remember this is 2,3-dimethyl, right? 2,3-dimethyl plus pent plus what? 2-ene. So if we put everything together, the name of the compound will be what? 2,3-dimethyl pent 2-ene. So let's see whether the option is there. Remember 2,3-dimethyl pent 2-ene. Write that down. 2,3-dimethyl pent 2-ene. 2,3-dimethyl pent 2-ene. That's option what? D. Option D. Question 5. Which of the following is not true about glucose and fructose? They are structural isomers. B. Reduced Fehling solutions. C. Can be obtained by the hydrolysis of starch. D. Are readily fermented by enzymes. Glucose and fructose are what we call what? Carbohydrates. And what type of carbohydrates are they? They are what? Monosaccharides. What we call what? Simple what? Part of what we call simple sugars. And both of them have the formula C6H12O what? O6. C6H12O6, right? So which means then what? Carbohydrate. What are carbohydrates? Carbohydrates are simply organic compounds that contain carbon, hydrogen, and what? Oxygen, with the general formula CxH2O. Why? Or we can also define them as organic compounds that contain carbon, hydrogen, and oxygen, in which the ratio of hydrogen to oxygen is 2:1. The ratio of hydrogen to oxygen in any carbohydrate is always what? 2:1, right? So in this case, our X is the same as our what? Y, right? X is the same as Y, but not in all cases. In some cases, X is not always the same as what? Y, like starch. Starch is what? C5H10O. Starch is C6H10O what? 5. So they are not always what? The same. You can see here, X and Y are what? Different. So now, let's come back here. Glucose and fructose, since they share the same molecular formula, that's this. Since they share the same molecular formula, C6H12O6, they are what? Structural what? Isomers. Because the glucose is an aldehyde, or what we call an aldose, while the fructose is what? A ketone or a ketose, right? While this one is what? An aldose. They have the same molecular what? Formula. So they are structural what? Isomers, which is correct. Now, reducing of what? Fehling solution. Glucose are reducing sugars. But some schools of thought will tell you that fructose is also reducing sugar. Well, the argument is that fructose can undergo a process known as what? Tautomerism to form what? Glucose, right? And once it does that, then it can also reduce what? A Fehling solution. But fructose on its own will not be able to reduce Fehling solution. So that option B is neither here nor there, right? But let's see if there's no other option that is very clear about the differences between glucose and fructose, right? Then we'll come forward option B, right? C, they can be obtained by the hydrolysis of what? Starch. Yes, when you hydrolyze starch by boiling starch with what? Water. Maybe in the presence of what? Acid hydrolysis of starch. what will happen? The starch will be converted to what? C6H12 what? O6, which can be a mixture of what? Glucose and what? Fructose. Starch is a polysaccharide, or what we call what? A complex sugar. So as a complex sugar or a polysaccharide undergoes hydrolysis to form a simple sugar or a monosaccharide like glucose and what? Fructose. So C is correct. Now D, they are readily fermented by what? Enzymes. That is not correct. We know that glucose undergoes fermentation. That is, it's acted upon by microorganisms, enzymes, specifically what? Zymase, in the absence of air to produce CO2 gas and what? Ethanol, C2H5OH. So 2 and what? 2. This is the fermentation process, which is always undergone by what? Glucose. Fructose cannot be fermented by enzymes. So that option D is not correct. They are not readily fermented by enzymes. It's only glucose that is always readily fermented by enzymes, and not fructose. So you can see that option A to C is relatively what? Correct for both of them. But option D is wrong, because fructose are not readily fermented by what? Enzymes. It's only glucose that can be fermented by enzymes. The correct answer is what? Option D. Question 6 and the last. The major raw material in plastic industry is, wow. We spoke a little about this in our last tutorial where we were looking at cracking. We said that the major byproduct of cracking is always what? Ethene, right? Ethene, you can also get hydrogen from cracking, right? But that ethene, being the major byproduct of cracking, is always used as a raw material in the plastic industry, right? This question is on the uses of organic what? Compounds. Ethene is the major raw material in plastic industries. It starts with ethene. From ethene you can get different other types of what? Compound. From ethene you can get chloroethene, right? From ethene you can get polyethylene, polyethylene or polythene. From ethene you can also get chloroethene, which from there you can get polychloroethene. That's your PVC, polyvinyl chloride. From ethene you can get styrene, and from styrene you can get your polystyrene. So from ethene you can get your Teflon, right? That's tetrafluoro what? Ethene. So ethene is the major raw material in plastic what? Industry. Let's look at other options. So apart from being a major raw material in the plastic industry, ethene is also used for ripening of what? Fruits. These are the two major uses that are always what? Examinable in your JAMB. They are the two favorite uses of ethene that will always come out in your what? UTME, right? Use of ethene for ripening of fruits, and also used as a raw material in what? Plastic industry. Are we together? Another one is also the use of derivatives of ethene like 1,1,2-trichloroethene and 1,1,2,2-tetrachloroethene as cleansing agent for removing what? Stains in laundry, right? Let me write out those uses. Ethene for making what? Plastics like polyethylene, polyvinyl chloride, use your PVC, your polystyrene, etc. Ethene is also used for what? For ripening of what? Fruits, right? It's also used for making cleansing what? Agents in laundry, or you can call it stain removers like 1,1,2-trichloroethene and 1,1,2,2-tetrachloroethene. They are used in laundry for removing what? Stains from fabrics. Then sulfur. Sulfur is used for making what? Germicide. It can also be used for making matches, etc. Ethanol can be used as a solvent for perfumes, can be used as a preservative, can be used as an antiseptic. Most importantly, it's used for making what? Beverages. Alcoholic what? Beverages. Ethanol is an alcohol. Alcoholic beverages like your beer, your whiskey, and so on and so forth, right? Then your ethane. Ethane is what? An alkane that is used for what? Fuel. Used as a domestic fuel for what? Cooking. As a cooking what? Gas. And also for making other what? Compounds. Of course, ethanol can also be used for making other compounds, right? So these are some of the uses of this organic compound that are always what? Examinable, that you will see frequently in your what? UTME examination. So take note of them. Sulfur is used as a germicide for making what? Matches, heads, and also for making creams, right? For making creams and cosmetics, right? So sulfur can be used for that too. hair creams, cosmetics, and the rest of them. Then ethanol is used, of course, as a solvent for perfumes, can be used as a preservative for your food, sterilizer, right? Sterilizer or antiseptic. Ethanol is used for preserving your cakes, right? They also used for making alcoholic beverages. Then your ethane now, not ethane. Ethane is used as what? A domestic fuel, which is the major function of what? Of alkanes, right? Now let me add one. Ethane, though that one is not here. So ethane is used as a fuel in miners' lamp, and also using acetylene flames for what? For welding of what? Metals. That's ethane. So please take note of all these uses. You may come across them in your examination. All right. So the answer to this question is what? Is option A, which is ethane. So that brings us to the end of our tutorial for today. If you learned anything from this tutorial, kindly drop your comment. We want to read your comment, want to read what you think about our tutorial. Is there any way you think we can improve on it? Please drop it in the comment section, right? So drop your comment, hit the like button, and of course subscribe to this channel if you are yet to do so. If this is your first time here, there's so many more things to learn, especially in this period that we are preparing for JAMB. So please subscribe and turn on your notification bell to always stay updated with our new uploads. Remember, excellence is not a destination, it is what? A journey. So keep improving on yourself until I see you when I'll see you.